Hello ladies and gentlemen, this video is about hurricanes. Okay, so what's a hurricane? A hurricane is a tropical cyclone. Depending on the region, hurricanes are also called typhoons or cyclones. The principle is always the same. Hurricanes only occur in regions where trade winds blow. This is because a huge bunch of sunshine is needed for hurricanes to form. Moreover, hurricanes only form at sea and not above land. The violent cyclones on land are called tornadoes. So, there's two things you can remember about hurricanes if you feel like it. First, they only form in regions where trade winds blow with a lot of sun, and only at sea. And what's also helpful to remember, the water temperature must be at least 26 degrees centigrade for a hurricane to form. Why does a hurricane need these conditions? It has to do with the formation of hurricanes. With hurricanes, the air flows upwards in a spiral, like here. Two processes are important for the formation of these vortexes. First, air rises upwards, and second, the air moves in a circle. Together, this results in the typical spiral movement. Let's have a look at how the air rises. The water plays a crucial role here. When the sun heats the air above the water, the air takes up a lot of water, which is then present in the air in the form of water vapor. Warm air is lighter than cold air. That's why the air, with all the water in it, rises. At some point, the water contained in the air condenses. This means that clouds are formed. So, clouds are forming. But here's the thing. When the water condenses, a great amount of energy is produced. This energy also heats the air, which allows it to expand again, and it continues to rise. It still contains a bit of water vapor, which then condenses at higher altitudes. Condensation can be seen as a booster that drives the air upwards. This booster catapults the air even further up, which creates even more clouds. High above the ground, the condensation and the production of energy will eventually grind to a halt. Then, the cold air moves away to the sides to sink down again. And because it pulls clouds to the sides with it, this then looks like, well, like a mushroom. The longer a hurricane sweeps over warm water, the more watery air rises. This causes more and more clouds to form, and the hurricane gets bigger and bigger. The hurricane gets power over warm water. So, the most damaging hurricanes are those that drag across warm water for a long time. Okay guys, you now know why the air rises in a hurricane. Now, we're gonna discover why hurricanes go round in circles. Let's first take a look at the eye of a hurricane. In other words, the area in the middle. Just imagine it's a tube, or, since you're watching online, a series of tubes. Within the eye, the temperature is approximately the same in the external parts of the eye as at the center of it. This means that there's air pressure even in the eye of a hurricane. So, if we have two air parcels, these do not have to balance each other out, since they have the same air pressure. The result is that there is no wind blowing in the eye of a hurricane. Okay, so in the eye of a hurricane, there's no wind going from right to left. However, there's still air moving from top to bottom. Contrary to the sides of the hurricane, the air in the eye sinks. Even meteorologists do not yet know exactly why this is the case. But you should remember the following. Because the air sinks, no clouds form right above the eye. Also, the temperature inside the eye is higher than outside. This is why we have lower air pressure in the eye than outside of it. A low forms inside and a high outside. As always, the air wants to escape from high pressure and go towards low pressure. Remember that inside the eye, there is no air movement from left to right, but only from top to bottom. But there are winds blowing into the eye from outside of it. However, that still doesn't explain the rotation. To help us understand, let's take a look at the eye from above. Here, we see the same as before, but from above. Because the thing is, the winds are also deflected. In the northern hemisphere, they are deflected to the right, and in the southern hemisphere, to the left. That's due to the Coriolis force. Here is an example for the northern hemisphere. All winds are deflected to the right by the Coriolis force. In the southern hemisphere, it's the other way around. In the northern hemisphere, a counterclockwise circular rotation forms around the eye. In the southern hemisphere, it is the other way around, so clockwise. There are no hurricanes at the equator, by the way, because there is no Coriolis force. Crazy, right? Okay, so we have rising air due to the condensation of water vapor and a circular motion due to the Coriolis force. Taken together, this results in an upward spiral movement. What should you guys take away from all this? Hurricanes form in the trade wind zones and always above water. Warm, watery air rises away from the ocean, and it is boosted even higher by the formation of clouds. The more water a hurricane can absorb over the sea, the bigger it gets. And the rotation is caused by the Coriolis force. Catch you later! Ciao!